Okay, we just finished a video where we looked at a trig review, and briefly, I can have a vector and I could have a theta coming off of that x-axis, and when I look at that, that's my opposite, and this is my adjacent, so this would be sine and cosine. I could look at that same vector coming off the y, call that phi, and now my x is the opposite, which is sine, and then the y is adjacent, which is cosine, because it's touching that angle. Okay, touching versus opposite. Okay, another way that we can simplify this is we can look at what's called rise and run. Okay, and I might, by geometry, if I'm looking at a truss, okay, I might have the dimensions given as a 10 foot, so that hole is 20. The height is, say, 10. So if I want to figure out the components, okay, the x and y components of basically this force vector, instead of going back and calculating all of these angles in the truss, which I could do, but that's a lot of extra work, I can note that this triangle has a rise of 10 and a run of 10, and I can use Pythagorean theorem. 100 equals the square root of 200, so we can just call that 10 root 2, and there's my hypotenuse relationship. So if I have a force that's acting in this member, and I have a force of 100 pounds acting in that member, I can now say that the y component of that is going to be 100 pounds times 10 divided by hypotenuse. And the x component is 100 pounds, and we can also, again, 10, and we can divide by that hypotenuse. And it's so much easier than having to think about angles and which is sine and which is cosine, because the y divided by hypotenuse, the x divided by hypotenuse. Typical things that we'll see are 3, 4, 5s. So 9 plus 16 square rooted is 5. We'll see 1, 1 square root of 2. Let's see, we might see 5, 12, 13. So these would be typical rise, runs, hypotenuse that you're going to be working with in statics and strengths. And again, if I want to know the x component, the y component, it's 5 over 13. The x is 12 over 13 of whatever that length, force, whatever. Here the y component is 1 over root 2. The x component is also 1 over root 2. Here the y would be 3 over 5. Here the x is 4 over 5. And I now don't have to worry about an angle. I don't have to try to figure out, is this sine, is this cosine, what am I looking at? I can just look at the ratio of the rise over hypotenuse or the ratio of the run, okay? So we'll review this when we get into cables and trusses, but this will often be what we use instead of a theta and phis or betas or whatever. But you cannot combine the two. You do not want to try to use a cosine theta 3 over. Okay, I see a lot of students doing that. You need to separate it. You're either going to use theta, sine, cosine, tangent, or you're going to use the rise and run.